All right, David Kahn here with another question from the question bank in the style of what you find in your Hayes and Harris Math SL textbook, Chapter 9C.1. And in this question, we're looking at the sine and the cosine rules. So in this question, we're told about points P, Q, and R are markers of a triangle on level ground. And the paths PQ, QR, and PR as shown in this diagram. QR is the length 9 kilometers. The angle PQR is 35 degrees, and the angle PRQ is the angle 25 degrees. So all of the information up here appears to be in the triangle below. Now using that information, we're going to try and find the length of PR. So what we're given is two angles and one side, and we'd like to know another side. So the rule that relates two sides to two angles would be the sine rule. That would make a lot of sense. So for part A, we'll go with the sine rule, which says that side A divided by the sine of angle A, that's the angle opposite side A, is equal to side B over the sine of angle B, that's the angle opposite side B. So if we want the side PR, we need the angle opposite PR, that'd be Q, we have that. We also need one more side, that's this one, and the angle opposite it, which is unknown in this case. So we need this angle QPR. Well, the angle QPR is one of the angles in a triangle, and we know the other two, and we know that the sum of all the angles in a triangle must be 180 degrees. So if we start with 180 degrees and take away the known angles, 35 degrees and 25 degrees, we get the angle QPR, and it gives us a total of 120 degrees. Now, knowing that information, we can substitute into our sine rule. We want to know the side PR, and the angle opposite PR would be 35 degrees. Then we know another side, that'd be QR, which is 9 kilometers. And we just found that the angle opposite that side was 120 degrees. So that'll be the sine of 120 degrees. To solve for PR, I'll multiply the sine of 35 degrees to the other side. And we'll have to calculate. Now, 120 degrees is a major angle that we need to know the unit circle for, but 35 is not. So we'll have to use the calculator. To solve this, first we'll check that we're in degree mode. So we'll go Home, Settings, Document Settings, and we'll look for the angle. Angle at the moment is in radians. We want it to be in degrees. So we'll select degrees and OK. And now our calculator pages should be in degrees. We're going to multiply the sine of 35 degrees by the fraction 9 divided by the sine of 120 degrees. When we perform that calculation, we find that the result is 5.96, and the units were given in kilometers, and so the result is 5.96 kilometers to 3 significant figures. Now let's go to part B. Part B says that Tom sets out to walk from Q to P at a steady speed of 8 kilometers per hour, so he's going that way. Meanwhile, Alan jogs from R to P, that's this way, at a steady speed of A kilometers per hour. They're meant to reach P at the same time, having set out at the same time, so we need to calculate what velocity Alan should be running at in order to achieve that. Let's take a look. Well, in this case, we're working with velocities and distances, so we'll start by saying that distance is equal to velocity times time. This means a couple of different things. This means that the distance traveled by Tom should be equal to the velocity traveled by Tom times the time that he travels for. and the distance traveled by Alan should be equal to the velocity traveled by Alan times the time that he travels for. But these two t's should be the same, because they're meant to arrive at the same time. So if we want to find information relating the two, we'll solve each of these for t, and we'll get that the distance for Tom divided by his velocity is that time, and the distance for Alan divided by his velocity is that same time, which allows us to combine these two expressions into dt over vt equals dA over VA. Similarly, the velocity for Alan is what we're looking for. It's A. So I'm just going to rearrange this and say dt over vt is equal to dA over my unknown velocity A, which was given in the question. Now, if I want to solve this for A, there's a lot of different ways I can do it. I can find dt, vt, and dA. dA is known as what was asked in part A. That's this distance, PR, and that's 5.96. The velocity for Tom is also known, but the distance is not known. And so we would have to find that, and we could use it using sine rule or cosine rule. I'm going to try and find it using a sine rule method. I'm going to do it in a bit of a different way, though. What I'm going to do is I'm going to rearrange this to find the ratios of the distances. So I'm going to get the distance traveled by Tom divided by the distance traveled by Alan is equal to the velocity of Tom divided by the velocity of Alan A. All I did was I multiplied vt to the other side, and I divided dA to the other side to get a ratio in terms of the distances. And the reason I did that is because I can get a ratio for the distances using the sine rule. The sine rule tells me that the side A divided by the sine of angle A should be equal to the side B divided by the sine of angle B. In this case, I'm interested in my two distances, dt and dA. The angle opposite of dt, the distance traveled by Tom, that's this distance, would be 25 degrees. So that's dt divided by the sine of 25 degrees. Then we have dA divided by the angle opposite the path that Alan travels, so that's dA, and the angle opposite is 35 degrees. I'm going to rearrange this, though, to get the same ratio dt to dA. So I'll divide dA to the other side, and I'll get dt over dA, and I'll multiply the sine of 25 to the other side, and I'll get the sine of 25 degrees over the sine of 35 degrees. This allows me to make a substitution. I'm going to sub 1 into 2. And instead of dt over dA, I'm going to write vt over A. And I'll get vt over A is equal to the sine of 25 degrees over the sine of 35 degrees. To get A by itself, I'm going to multiply A to the other side, and I'll get vt is equal to A sine of 25 degrees over the sine of 35 degrees. And then I'll divide sine of 25 over sine of 35 to the other side. So basically that's a multiplication of sine of 35 degrees and a division of sine of 25 degrees. And that gives me A is equal to the velocity of Tom, which was given in the question to be 8 kilometers per hour. And then we'll have the sine of 35 degrees divided by the sine of 25 degrees. Neither 35 degrees nor 25 degrees are major angles on the unit circle that we need to have memorized, so we'll have to turn to the calculator. I already know from earlier in the question that I'm in degree mode, so I can go right in and multiply 8 by the sine of 35 degrees divided by the sine of 25 degrees. And what I get is that Alan must travel with the velocity of 10.9 kilometers per hour to 3 significant digits. All right, let's take a look at part C now. In part C, it says we're now talking about a point S, which is on the line P to Q, such that the distance from R to S is twice the distance from Q to S. So let's go ahead and call that distance x, and so this will be twice that distance, 2x. We're asked in part C to find the length of QS, and that's that unknown length, x. To solve for that, we're going to need to know some information about this triangle, but we know it from before because it's the same triangle PQR, just with an extra line, which means that this base is the same length, 9, and this angle is the same angle, 35 degrees. So what I'd like to do is I'd like to relate an angle, a side, two sides, and an angle, so all three sides and an angle, and the rule that relates all three of those would be the cosine rule. So for part 3, I'm going to turn first to the cosine rule. For part C. The cosine rule says that one side squared is equal to the sum of the squares of the other two sides, take away a correction factor of twice the product of those sides times the cosine of the angle between them. In this case, we have our three sides. Looking at this diagram, this is the angle that we know. So C must be the side opposite that angle. In this case, it's 2x. X and 9 must be the other two sides. And so we'll get 2x squared is equal to x squared plus 9 squared. Take 2 times x times 9 times the cosine of 35 degrees. 2x squared, that's 2 squared times x squared, is 4x squared. 9 squared is 81. And then we have 2 times x times 9 times the cosine of 35 degrees. So that's 18 cosine of 35 degrees x. We'll put things together in like terms. We'll subtract x squared and get 3x squared. Add 18 cosine of 35x to the other side. And then we'll subtract 81 to the other side. And that leaves us with a quadratic expression is equal to 0. To solve this, we could try factorization, but 18 cosine of 35 is not going to work out nicely at all. We could try completing the square, we could try a lot of things like quadratic formula, but we have our calculator on this question, so let's use some calculator tools. Let's find all of the possible solutions to this polynomial expression using the tool polyroots. To use polyroots, you just type POLYROOTS, and the first thing that you enter is a polynomial expression, which is meant to be equal to 0. So what we're going to enter into polyroots is just this expression, but the calculator is assuming that that expression is meant to be equal to 0. In our case, it is. So we'll have 3x squared plus 18 times the cosine of 35 degrees, and I know I'm already in degree mode, times x. Take away 81, then you press comma, and what you list is the variable in the expression, which would be x. So you just type x and close the brackets and press enter. And what it returns to you is all of the possible solutions to that polynomial expression. So our solutions are that x could be equal to negative 8.020 or 8.21, or x could be equal to 3.29 to 3 significant digits. That's our two solutions from here. However, since x is meant to represent a length, we can throw away the negative solution and we'll keep the positive solution, and that would be the length of the line that we were asked to find, QP. So what we'll say in conclusion is that QP should be equal to 3.29 kilometers.